Magnetic fields are everywhere, playing a critical role in many natural phenomena and technological applications. In this video, we'll dive deep into the science of magnetic fields, how they work, and why they are so important to both our everyday lives and the larger universe. At the most fundamental level, a magnetic field is a region of space where a magnetic force can be detected. These fields are created by moving electric charges, such as when electrons flow through a wire or when magnets are present. The strength and direction of a magnetic field are determined by the source that produces it, whether it's a simple magnet, an electric current, or the Earth itself. One of the most well-known and important magnetic fields is the Earth's own geomagnetic field. The Earth's magnetic field is generated by the motion of molten iron and other metals in the planet's outer core, a process known as the geodynamo. This magnetic field surrounds the Earth, forming what is called the magnetosphere. The magnetosphere protects the planet from harmful solar radiation, which would otherwise strip away the atmosphere and cause massive damage to life on Earth. This shield is crucial for protecting our environment from the solar wind, streams of charged particles emitted by the sun that could otherwise affect the Earth's delicate climate and life-supporting systems. The Earth's magnetic field is not only essential for life but also plays a vital role in navigation. For thousands of years, sailors and explorers have used magnetic compasses to find their way across the oceans. A compass works by aligning a magnetic needle with the Earth's magnetic field, helping travelers determine their direction. Today, modern navigation systems, including GPS, also rely on understanding the Earth's magnetic field to calculate positions accurately. The strength of the Earth's magnetic field varies across the globe. It's strongest near the poles and weakest at the equator. Interestingly, the magnetic poles are not fixed and have been known to reverse in a phenomenon called geomagnetic reversal. These reversals happen roughly every 200,000 to 300,000 years, but the exact cause is still not completely understood. Scientists speculate that the shifting movements of molten metals in the Earth's outer core influence these magnetic pole shifts. Beyond Earth, magnetic fields are crucial in other areas of space science. The Sun, for example, generates a powerful magnetic field that influences solar activity. Sunspots, solar flares, and coronal mass ejections are all manifestations of the Sun's magnetic field in action. Solar flares release massive bursts of energy and charged particles into space, and when these particles interact with the Earth's magnetic field, they can cause disruptions in communications, GPS systems, and even power grids. These magnetic disturbances are known as space weather and can have serious consequences for modern technology, making the study of magnetic fields in space a key area of research. Magnetic fields also influence the behavior of charged particles in interstellar space. In galaxies and nebulae, magnetic fields interact with the plasma, charged gas particles, leading to the formation of stars, planets, and even black holes. The magnetic fields in these regions help regulate the flow of gases and dust that eventually form the building blocks of celestial objects. The magnetic fields of galaxies can also influence their overall structure, and by studying them, scientists can gain deeper insights into how galaxies evolve over time. On a more practical level, magnetic fields have revolutionized technology. They're a fundamental part of motors, which convert electrical energy into mechanical energy. Electric motors are used in everything from household appliances to electric cars, and their functioning relies on the interaction between magnetic fields created by electric currents and permanent magnets. Magnetic fields also enable some of the most important advancements in modern technology, such as data storage in hard drives, magnetic resonance imaging, MRI, and even wireless communication. In hard drives, magnetic fields are used to store digital information. The disk inside a hard drive is coated with a magnetic material, and data is written onto the disk by changing the magnetic alignment of small regions called magnetic domains. These ones and zeros are read by a magnetic head that detects the changes in the magnetic fields, allowing computers to access and store vast amounts of data. This technology has been critical for advancing computing and the storage of digital information. MRI machines, commonly used in medical diagnostics, rely on powerful magnetic fields to generate detailed images of the inside of the body. In an MRI, a patient is placed within a strong magnetic field, and radio waves are used to interact with the hydrogen atoms in the body. These interactions cause the hydrogen atoms to emit signals, which are then captured and converted into images that allow doctors to examine tissues, organs, and even blood vessels with remarkable clarity. Magnetic fields also play a role in everyday devices that most of us use without even thinking about them. In smartphones, for instance, magnets are used in speakers, microphones, and even in the motor of the phone's vibrator. Without these small but powerful magnets, many of the features we rely on daily would not be possible. The influence of magnetic fields extends beyond technology into the realm of biology. Certain animals, including birds, turtles, and even some bacteria, possess the ability to detect magnetic fields, a phenomenon known as magnetoreception. These animals use the Earth's magnetic field to navigate during long-distance migrations. While the exact mechanisms are still not fully understood, scientists believe that magnetoreception involves specialized cells that can detect changes in the magnetic field, allowing these animals to find their way across vast distances with remarkable accuracy. In addition to the natural magnetic fields on Earth and in space, human-made magnetic fields are also at the forefront of scientific research. For example, magnetic fields are used in particle accelerators like the Large Hadron Collider to manipulate and direct subatomic particles. The ability to control particles using magnetic fields has opened new frontiers in particle physics and is helping scientists investigate the fundamental forces of nature. Magnetic fields also play an important role in renewable energy generation. Wind turbines, which convert kinetic energy from the wind into electrical energy, use magnets in their generators. Similarly, the process of generating electricity from hydropower, geothermal, and even solar power often relies on the interaction of magnetic fields to generate and convert energy efficiently. As the world continues to seek sustainable energy solutions, the importance of understanding and harnessing magnetic fields will only increase. Magnetic fields are one of the most powerful and widespread forces in the universe. From the magnetic shield that protects Earth from harmful solar radiation to the devices we use every day, their influence is all around us. Whether it's in the realm of space exploration, renewable energy, or medical technology, magnetic fields are indispensable to modern life. With continued research, we'll keep unlocking new ways to leverage the power of magnetism for both practical and scientific advancement.